Welcome, Math 10 students. This is Ms. Parsons. Today we're talking about Skill 16, representing exponential functions. So we have some definitions for you. The first is that an exponential equation has at least one with a numerical base that is raised to an exponent with a variable term. So in this case, an example of that could be y equals 2 to the x power. So we have the numerical base, which is 2, and the exponent with the variable in it, which is just 1x, or 1.05 raised to the 5x power. So then we have the general form of an exponential function, which is f of x equals a times b to the x. A represents our initial value and b represents our base. You can write an equation to model an exponential function from either a pair of input-output points, like in a table, from a graph, or even from a verbal description. So here's your steps or your recipe to write down these exponential functions. The first thing you're going to do is determine your initial value or amount. So remember, that is your a value, and we are going to substitute that value in for a in the general form. Then we want to know, is this a growth or decay? So we're looking at b. So remember, if it's growth, b is going to be greater than 1. If it's decay, b is going to be less than 1. And then we're going to substitute that value of b into the general form. So in our first example, I have Sakai who invests $500 in a bank account that pays 5% interest compounded annually. This is a table that shows the amount of money to the nearest dollar in Sakai's account over time if she chooses not to put any more money into her account. So in 0 years, she has $500, 1 year, $525, 2 years, $521, 3 years, $579, so on and so forth. So I want to write a function to determine the amount of money. So in this first box, it asks, is this exponential? This is an example of exponential growth. So why is it an example of exponential growth? Well, for one, please don't put your money in a bank where it is going to exponentially decay. You're not going to be very happy. Secondly, since we know this is growth because of that reason, that it is growing at a rate, we know that b is greater than 1. Our initial amount, that's how much money Sakai put in there to begin with. Well, she put in $500. And the amount of change from 1 year to the next. We know this isn't just a set amount. It's not like she gets $25 per year, but we know it's a percent. So that is 5%. And so our b in this case is 1.05%. And I get that because I know b is over 1. So I'm going to take 1 plus that 0.05, that's as a percent, to get 1.05. And x represents the time in years. So remember, I have that general form, f of x equals a times b to the x power. And I know my a is 500. My b is 1.05. And I know that my x is time in years. So really, for these exponential functions, we just need to find a and b. In example 2, doctors have found that the amount of a certain drug in a patient's body decreases exponentially at a rate of 15% per hour. The patient took 800 milligrams of drugs, and now he has about 157.5 milligrams left in his body. Which equation can be set up to solve for the number of hours since the patient took the drugs? So we want to use our 4 steps that I had showed in slide 2. And one says determine the initial value. Okay, that's our A. Okay, the initial value that this person has in their body is 800 milligrams. Okay, so we're going to substitute that in to our equation for A. But I still have B to worry about. Step 2, is this growth or decay? Well, it said at the very beginning that it decreases exponentially. So this is going to be exponential decay. Which means that B is going to be less than 1. So I'm going to take 1 minus that 15% as a decimal, 0.15, to get what I need here. And I'm just going to leave it like that because I know that is kind of how this is set up. And then substitute that into the general form. So f of x equals 800 times 1 minus 0.15 to the x power. So which one matches here? Oh, f of x is going to be 157.5 because that's how much he has left in his body. So it's going to be A. Okay. Example 3, a certain substance decays at an exponential rate. Okay, we're going to need that later. The amount of the substance on any given day is 50% of the amount the substance the previous day. Which function best models the amount of 1,000 grams of the substance remaining after X days? So step 1, what's the initial amount? That's going to be 1,000 grams. Okay, B, or step 2, I need to know what B is, and we know that it's a decay, so it's going to be 1 minus that 0.5, which is 0.5. And so then I'm going to plug it in. I've got A, got B, so I've got 1,000 times 0.5 to the x power. So that one matches this guy. So your answer is B. Okay, last one. The population of Jeremiah's hometown during the past 30 years is modeled on the graph shown. Which equation best represents the population modeled on the graph? Okay, so just looking at this graph, I know that it's growing, right? So I know that it's an example of exponential growth, but I need to know what my initial value is. How much did we start with? So at year 0, we started with 20,000 people, but in this case, just 20, because it's written in thousands. So I don't know what my percentage is here. Okay, I know it's a growth, so I know that B is going to be greater than 1, but it doesn't tell me like in the past 2 where it says it's 50% greater than last year's. So I need to find this. So I am given another point here. I'm given this 2036 here. So I'm going to use that in my equation. So I have 36 equals A, which is 20, times B, which I don't know, raised to the X, and in this case, that's the 20 power. So I put my Y here, aka my f of x, and I put my x here from that second point, and that A, and that A value that I'd figured out from where my y-intercept is. Okay, and I'm going to solve this. Never solved, everybody's solved an exponential equation before. So 36 divided by 20 is 1.8 x to the 20th power. Okay, and then I don't want x to the 20th power, I just want x. So I have to find the 20th root of both of these. Okay, so the 20th root of 1.8 is going to give me x. And when I put that in a calculator, I get approximately 1.03. Okay, so somehow my x or my b magically changed to an x. Sorry about that. It's a super habit because we're always used to solving for x's, but this is really my b value. So when I plug it into my general form, f of x equals a was 20, times b, 1.03 to the x power. So here, my answer choice is A.